So we learned fraction into, we went very deeply into fraction, into explaining this definition, learning this definition, what exactly a fraction is. And in a previous video, we discussed about proper fraction. Though I think that I covered this topic in a very detailed way, but I think we should do one more separate video on this proper fraction. Okay, so here this video is about specifically about proper fraction. I told you in the previous video that whatever we discussed, that was all about proper fraction. Okay, but once more, let's do it once more, and let's say that you have a iron rod. So this is a iron rod. Let's say that the length of this iron rod, let's suppose that the length of this iron rod is 4 meter. Okay, I cut this iron rod into two equal parts. From the center I cut this, so this is the cut. Therefore now the length of this will be 2 meter and this portion will be 2 meter, right? Okay, this rod of similar length, of 4 meter, let's take two rods. Let's take two rods. This is one rod of same length. Okay, let's suppose this is another one. Both are of 4 meter and 4 meter. Just suppose them that they are of 4 meter. Same length. And why? Because in this case, we are going to base our discussion on what we discussed here. In this example, we took one pizza as a whole, and in the next example, we took 4 pizza as a whole. We took this collection as a whole, whereas in this example, we took one pizza as a whole. In this example, we are taking one single rod as a whole, and in this one, we are taking collection of two the same length rods as a whole. This is our one whole or single rod. This is one. So if I divide this into two equal parts, this collection is also having two rods of equal length, right? 4 meter and 4 meter. So this will be one part. Okay, in how many parts this rod has been divided into? You will say in two parts. So this part will be the first part, and one part, and the total number of parts this rod has been divided into. This will be another one part. So another one part, and out of how many equal parts? Two parts. One part and two parts. Now in this example, we are taking this collection as a whole. This is as a whole or single unit. And this is the one part of this collection, and this is another part of this collection of whole. So this is one part. For those of you who haven't watched this video, please go to this video and watch it. Then you can understand it in a better way. So this is the one part of this whole collection. This will be one. How many parts we have? Total parts? We have two parts. One part, two parts. This is another one part, and divide by 2. Okay. Let's say that now I divide this rod, that is this of the same length, it is 4 meter. I divide this rod into 4 equal parts. Now this is here, and this is here, and this is, it's here, it's here, and it's here. Okay. These are 3 cuts. If you are not, I know that these are of not equal lengths, but for our discussion, just suppose them are of equal lengths. And since I have divided this into 4 equal parts, therefore this will be 1 meter, this will be 1 meter, this will be 1 meter, and this will be 1 meter. Therefore, I have divided this whole into 4 equal parts of 1 meter, 1 meter, 1 meter, and 1 meter. Now take the same rod of same length here, and we are now taking 4 rods. One rod, then another rod, then another rod, then another rod. Now our hole, in this case the single rod was a hole. This is one example. In another example, the collection of these 4 rods is our hole. Okay, is our hole. This is our hole, or a single unit. So we'll base our discussion on fraction on this hole. This is one part, so we'll say one part, and we have divided this whole rod into 4 equal parts. This is another one part, and this whole rod has been divided into 4 equal parts. This is another one part, and this rod has been divided into 4 equal parts. This is another one part, and this rod has been divided into 4 equal parts. Similarly for this one. This is one part out of 4 parts. This is another one part out of 4 parts. This is another one part out of 4 parts. This is another one part out of 4 parts. If a person A comes, let's go back to this example. If a person A comes and takes this part, A takes this part. Now in that scenario, A will have what fraction of this rod? He will have one part of this out of this two. In case he takes this one and this one also, this part and this part, now A will have 2 parts out of 2 equal parts, right? There is a total number of 2 parts. Similarly, A comes here, A takes this part. So now A has one part out of these 2 equal parts. If A takes this part also, this part and this part both, now A will be said to have 2 parts out of 2 equal parts, right? It's having 2 parts out of total number of 2 parts. Similarly, if A takes only this part, it will be said that A has one part out of this 4 parts. If A takes this one also, in that case A will be said to have 2 parts out of 4 equal parts. If A comes and takes this one also, this one, in that case it will be said that A has 3 parts out of 4 equal parts. If A turns out to be greedy and he takes this one also, this one, so in that case A will be said to have 4 parts out of 4 equal parts. Okay. Same thing here. If A is only having this one, so in that case it will be the only one part A is having. If A takes this one also, it will be said to have this one, so 2 parts out of 4. If this one, it will be said to have 3 parts out of 4. If he takes this one, and this one, so it will be said to have 4 out of 4. Now in all these cases, in this and in this, one single rod was considered as a whole, while in this case we were having a collection of objects as a whole. Here we took 2 objects, that is 2 rods as a whole. In this case we took 4 rods as a whole and we considered them as a single unit, and we based our discussion on that, and we did fraction on that. All these numbers, 1 by 2, 2 by 2, 1 by 2, 2 by 2, 2 by 4, 3 by 4, you know that they all are fraction, and they are fraction like we discussed here in a strict manner. Therefore they are proper fraction. Why proper fraction? Because proper fraction is a fraction in a true sense. What's the meaning of true sense? True sense means that a fraction is actually a broken part, a portion of a single unit or of a whole when you're considering them as a whole. So this is actually, whatever you are seeing here are proper fraction. Proper fraction are fractions in a true sense, in a true manner. Okay, And the most important thing is that whatever fraction we are looking at here, in all these cases, the numerator is less than or equal to denominator, but they are never greater than denominator. They are either less than or denominator. They are either less than or equal to, but they are not greater than. They are not greater than. Okay, big no. So if you see any such fractions where you have numerator smaller than the denominator, straight think of proper fraction. Okay, so I'll request again those of you who haven't watched the previous videos, please go and watch the part 1, part 2, and this is our part 3 video. In part 3 we'll discuss proper fraction. In the next video we will discuss about improper fraction. Thanks for watching.